All right, so we have the regular octagon. Octagon at each side, 8 vertices. Okay, you can see the octagon there. A triangle is formed by connecting the 3 randomly chosen vertices of the octagon. If you have a 3-point over here, when you connect the line, we have 1 triangles. Okay, what is the probability that at least one of the side on triangle is also side of octagon? So this type of question, when you make a triangle, but this triangle is okay, one side is also a side of octagon. Or this triangle also have a side on octagon side. You're gonna count this one. If you have this one, this point, and this point, this point. This is also a triangle with 3 points, but this is not satisfy the conditions. All side is not on this octagon side. This is not octagon side. This is not. This is not. But this triangle is not good for us. So the problem over here, they're going to asking you probability. What is the probability? What is the probability? The bottom over here, there's no restriction. Any triangle, so number of all possible triangle. What is the event? Desirable outcomes, successful outcomes is what? At least one side, number of a triangle, but this triangle at least one side, or 2 sides, not 3 sides there, right? Just make this one only 2 sides on this octagon side, but third one is not, only 1 or 2, okay? At least one side is also a side with octagons. So the problem over here, how we find all possible triangles? We have right 8 points there, 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8 vertices. Using the 8 vertices, can you find the number of a triangle? You can do that. If we have a 4 triangle, 4 point over here, 1, 2, 3, 4. This is a very small number of vertices. You can count over here. This one, 1 triangle, 2 triangle, another one different color, 3 triangle, and different color, 4 triangle. Okay, that's the 4 triangle. Wow. When you have a 4 vertices, it's a little bit confused, right, to find number of triangles. But I think on these questions, we have to use the formula because there is a formula. Or I think that formula, maybe you guys, some of you guys understand the formula, but some others did not learn this formula. But there's no way, okay? On this number 23, we need to use the formula, okay? There's no choice because what? Too many triangles out there. It's more than, I think, 100, more than 100. How can you draw the 100 triangles on this octagon? Really impossible, okay? All right, now let's learn some formula. If you have a 3 point, first one, I'm going to use a different over here. The first, if we have a 3 point over here, 1 point, 2 point, 3 point. When you got the 3 point, when we have a 3 point, now we have one triangle. Okay, that's the idea. If a 4 point, maybe more than one triangles. The rule is this way. When you choose 3, so here, when we choose 3 point, that means the symbol looks like this way. Out of what? N point. Okay, you can use this one. Out of N, we choose 3 point. That is, we said N choose 3. Okay, and combination 3. The formula looks like this way. Formula is N times, N minus 1 times, N minus 2 times, keep continue, still N minus, okay, I'm not going to do this one. Just like simple formula, okay? Just a simple formula. I don't want to make the confused. This is number of choice over here. 1, 2, 3 point. Okay, this is the number of point 3. But first one, you can choose all N point. Second one is 1 less than this number and minus 1. The next one is what? 1 less than this number and minus 2 choice. But there is no permutation. There is no order. So we have to divide by this number again. This number is now over here with factorial. This number is, we said, breaking order. The numbers breaking order. Because what? A, B, C, which choose what triangle? ABC triangle, BCH triangle, CBH triangle, but actually this is only one triangle, not 3 triangle. Is okay? So that's why we break the order. Just memorize this formula. If you have a 3 point, you choose only 3. The formula is what is that? We have a 3 prices over here. This is a 3 choice. Second one is a 2 choice. Last one is a 1 choice, but we need to break this number again. 3 factorial. You know the factorial, right? 3 times 2 times 1. 3 factorial is there. 3 times 2 times 1. So equals to 1. That's why we got the 1 triangle. That's the number 1. Use the formula, okay? The next one is, if we have a 4 point over here, 1 point, 2 point, 3 point, 4 point. But every point is not collinear. If you have 3 point collinear over here, this we set collinear. They don't make any triangles. This because they're flat, that is not triangle. So I assumes all points are not collinear, okay? In the same line, okay? All right, so this is okay. We have a 4 point. We're gonna choose how many ways to choose 3 point. Each choose give us 1 triangle. So we can try this one. This is 3 spot, same as before. 1, 2, 3 spot. The first one we have a 4, we start from this number, that 4 choices. Second one is 3 choice. Third, 2 choice. But you need to divide by the factorial of this number, break order. Break order. So 3 factorial equals 3 times 2 times 1. 3 times 2 times 1 is 6. This is a 6, canceled out. Yeah, we got the 4 triangle. We did already 4 triangles. 1 triangle, oops, this one. 1 triangle, 2 triangle, 3 triangle, here 4 triangle. Okay, a little bit confused, right? Anyway, there are 4 triangles. Just one more over here. Just one more. If we have 5 point, 1 point, 2 point, 3 point, 4 point, 5 point, maybe on the circle is okay, right? Because they're not collinear. If you 5 point on the circles, when you connect, right, the lines, how many triangles that they can make it? They can create 5 point when you choose 3. That is the number of triangles. 3 spots there, 1, 2, 3. So the first is a 5 choice, 5 times, 4 times, and 3, and divide, breaking order. A, B, C, B, C, that's the same triangle. We need the break order. 3 factorial is 1, 3 factorial. 3 factorial is 3 times, 2 times 1. So 3 times 2 times 1 is 6. This is 1 canceled out. 4 divided by 2 is 2. 2 is canceled out. So 5 times 2 is 1. We can create 10 triangles, right? A lot. It is okay. That is the number of triangles. Maybe you can extend this one. If we have a 4 point over here, wow, 4 point. They're not collinear. In this case, another one. How many lines can you create? How many lines can you create? If you have 2 point over here, you know that if you choose 2 point, you can make 1 line. 2 point, create, give us 1 line. Is it okay? If you have a 3 point, how many lines? 1, 2, 3. Okay, 3 point, which is 3 lines. 4 point, take this is 4 point. I'll make a line. 1, 2, 3, 4, 5, 6. 6 lines. So we can apply the formula. It's the same thing. Out of 4 point, we choose 2 point, right? That's the number of what? Lines. The rule is this is 2 spot over here. Write down 2 spot. First one is 4 times 3. But you need to break the order. 2 factorial. 2 factorial is 2 times 1, right? So cancel out. This is 1. This is 2. 2 times 3 is 6. That's the number of lines. Take a 2 point. 2 combination 2. 2 over here. 2 times 1, right? Now 2 factorial still 2 times 1. Same number. That's why we got the 1 line over here. Now we check this is a 3 point. We're gonna choose 2 point. How many ways to choose 2 point? Still 2 spot over here. By this time, we're not gonna use block anymore. Just a 2 spot over here. 3 times 2, isn't it? First one is 3, second is 2. 1 less than before. Over breaking order 2 factorial. This 2 factorial is 2 times 1, right? This is canceled out 2. So it is 3 lines. It's working every, depends on, how many point. They can make what quadrilateral, octagons, so you can make it. If you choose what, how many pentagon out of 13 point. We have a 13 point. They're all collinear, non-collinear. How many octagon can you make? No, how many pentagon? Octagon too much. Pentagon. How many pentagons? Pentagon has 5 sides. 13, choose 5 points. That gives us 1 pentagon. Okay, so this is what is that 5 spot. So 13 times, 12 times, 11 times, 10 times, 9, and divided by 5 factorial. 5 factorial equals 5 times, 4 times, 3 times, 2 times 1. A lot. Okay. So this combination is very useful. Okay. Without these formulas, this is actually very hard. Okay. It's impossible to get the right answer. Is it okay? Now we have 8 points of view. 1 point, 2 point, 3 point, 4 point, 5 point, 6 point, 7 point, and 8 point. Now let's apply the formula. How many triangles we can create? How many triangles can be formed using these 8 vertices? 8 combination 3, isn't it? That's right. That's the number of triangles. Find out. This spot. Okay, I'm going to just block still. If you like this one, 8 times, 7 times, 6. The next one, you break the numbers. 3 factorial. 3 factorial equals 3 times 2 times 1. Okay, when you cancel out, this is 6, 6 is out. There will be what? 56 triangles there. Wow, a lot. Okay, how can you make it 56 graph? Wow, impossible, okay? Less than 5 is okay, but more than 5 or 10, 20 is impossible. It takes too much time. And also that is not accurate. We don't know. They made a lot of one mistake. There are 56 all possible angles, 56. But we're gonna find the triangle, special triangle. At least one side is on this side of octagon. That's the second one. Okay, in this case, we can try this one. If we choose this point, one side only, at least is what? Case 1. Only one side is a side of the octagon. Second one is what? Case 2, 2 sides, they are all sides of the octagon. We can separate. All 3 sides cannot be the side of octagon. This is not triangle. It's okay? All right. So with this side, how many triangles can you make it? How many triangles can you draw? You can find 1, this point, or this point 2, this point 3, this point 4, not this one. This one, 2 sides. Each side has how many triangles? 1, okay, I'm gonna make this one. 2, 1, 2 triangle, 3 triangle, and 4 triangle with this side. 4 triangle. This is the same thing with this one, another 4, same situation, right? Also same situation. With this side, same thing. With this side, this is 1, 2, 3, and 4, isn't it? That's right. 3, 4. Okay. So with this side, another 4, how many sides? 8 sides. So actually, 8 times 4, each side is a 4 triangle. We have an 8 side. Okay, 1 side, 2 side, 3 side, 4 side, 5 side, 6 side, 7 side, 8 side. So there will be 32 triangles They have a side on the what? 7 side of octagon. Are you guys with me?
Mm-hmm.
Yeah, very good. Okay, the next one. Case 2, 2 side with this one, 2 side. This side and this side, 2 side. How many triangles? Only one. With these two, only this side, only one triangle available. Okay, only one triangle available. Second one, where is it?
8.
8, correct. This is what, 1. Okay, when you have one triangle, right? When you have a 2 over here, we start this point. Another triangle, 3 triangle, 4 triangle, 5 triangle, 6 triangle, 7 triangle, 8 triangle, 8 triangle over here. Yeah, this is 8 triangles. All right, now at least
So
one
answer
side
is
or
D.
2 sides.
Is
Yes,
the answer
I
D?
think so. 32 plus 4 is about 40 triangles. Both what side at least one of this side on octagon. So you can simplify, right? Divided by 4, divided by 4, that is 10 over 14. Oops, so we need more. Divided by 2 is about 5 over 7, right? That's this. Any questions about number 23? Okay, just memorize the formula, okay? That is not say, okay, this is not topics, okay, on your schoolwork. I understand this is a AMC 8, okay, to have like the competitions with others. And anyway, we have to learn this one, okay? There's no choice. Okay, a little at the best, okay? All right. Maybe next year, I'm gonna make some books for MC8 because the solution for MC8 organization or some other organizations, the solution answer key is so bad. That's not good, okay? A good solution for students to understand this, okay? Right. Maybe we try it next year. That is number 23, okay? All right, now move on number 24 over here. 24, what it is? We have a cube, yeah? Cube with all sides is equals. Okay, this is a midpoint. This is a midpoint. And R is the ratio of the area, cross sections, okay? EFG inside of here, okay? So we're gonna find the ratio. This bracket means area, okay? EJCI. EJCI is what inside, was EJ, okay, this is a shaded region, okay? Looks like square, I don't know. And the other one is area one page over this one. One page, this is one page, or this page. As I told you before, when they're asking you a ratio, okay, this is a ratio, isn't it? This is a ratio. Better use plug-in number. But this number should be a very, very looking good number, okay? This is you said good number. I'm going to take this is good number. This is divided by 2. This each side is 1, 1. That is a good number. Don't use 100, 100 or 88 or 77. This is a good looking number, number 1. So this side is 2. This side is 2. The area of this page is, one page is how much? 2 times 2 is 4. I'm going to write 4 here. That is 4. That's it. Okay, 34. Now we're gonna find the area with this side of the region. What is this side, they are all equal, right? Because this is vertices midpoint of opposite side. Vertices midpoint of the opposite side. This vertices or this point same thing. Vertices midpoint of opposite side. They are all congruent, equal numbers. So it looks like it's not square, right? This one is right angle. This is not right angle. This is not right angle. You gotta be careful, okay? This is not right angle. Maybe you can check it out. This is not right angle. Don't think this is the right angle, okay? That is not right angle, different. Maybe you can take a look in your room, okay? Just use the midpoint and take right the other corner of your ceiling. That is not right angle, we know that. Okay, so this is one, this is two. What is the length of this side? This side is square root 2 square plus 1 square, Pythagorean theorem. That is square root 5. Okay. Looks like square, but we don't know still. This side is 5 square root 5. This one 5 square root 5. Square root 5 and square root 5. Now check it out. When you have a square, all sides is equal, and also what is that? Average angles, corner angles is 90 degrees, right? So we cannot check it. Well, we don't know. The next checking is what is that? The next checking is diagonal. Diagonal always is equal, right? Diagonal always equal. Take a look. We check for you because we don't know. We don't have any information about the angles. Okay. Now still we can find what diagonals. Okay. All right. One of this one. That is not easy. I understand. Okay. But don't be pressed. This is new topics. Okay. This is a hard one. Let me see what is the number 24. Yeah, hard one. Even though I 10th grade, they don't know how to do this one. Sometimes 11th grade, what? They say they don't know. But if you know the formula, you can solve it, okay? This is diagonal. We are at this point, the middle point. Is it the same as this? They are parallel, right? JH, I'm gonna write down over here. This JH, this length equals to this length. It is okay? They just move down, it's the same length. This is 2, this is 2. What is the length of this one? Square root. This is the right angle. This is the right angle, perfect. So 2 squares plus 2 squares is square root 8. This is square root 8. Now take a look at the other side, this length. Wow, what is this? The other side. This is a vertex to the other side, opposite vertex. This is the actual diagonals of cube. This length is diagonal of a cube. Okay, so diagonal of a cube, I'm gonna write up, use this one. Okay, new graph. Okay, confused, right? This is a cube. It doesn't matter any rectangle solid. Where is diagonal? We have 2 different diagonals from here to here, or here to here, or here to here. I'm going to take this here. I'm going to take it this way. This is diagonal of a cube. All right. This is what diagonal of what? Not cube, of the square, right? The face. How can you find this one? If this side is A, width is B, height is C, the length of this diagonal inside a cube, diagonal is what you have to memorize. I'm gonna prove this today, so we don't have enough time. Okay, maybe later if you have a chance, I can prove this one. Okay, this is equal to square root a squared, b squared, and c squared. Very similar to Pythagorean theorem, right? Just one more because this is a cube, three-dimensional solid. Two-dimensional solid divided by a and b. This diagonal equals to a squared plus b squared. This is three-dimensional, just one more c squared. That is the length of a diagonal of a cube. Okay? But in this case, they are all equal, 2 to 2. In this case, a equals, b equals, they are all 2. This diagonal of solid equals to 2 squared is 4, b squared is 4, c squared is 4, square root 12. Is it okay? Yep. This length, square root 12. Okay, after that, how can you find the area with this? This is now rhombus because the diagonal is different. If the diagonal is equal, that is direct square, but this is not diagonals are equal. That is a rhombus. Actually, this figure is a rhombus. How can you find the area of rhombus if you have two diagonal? Yeah, you can use two diagonal. Red 12 times, red 8. Red, when you have a red 12 times, red 8, area of this big rectangle, you could from here to here, red 8, from here to here, red 12. It's actually half of that, right? Because this side, this side, this side, this side, they are equal area. So red 8 times, and red 2, and divided by 2. This is a red 96 over 2, right? 96 is what is that? Can you find the 96? 96 is 4, red, 6, because 96 is what? 4 times 6. So 4 is two numbers out. When you divide it by 2, which is what? 2 red 6. It's okay? That is 2 red 6. Now put this number over here. So what is the ratio? The ratio equals to 2 red 6 over 4 equals red 6 over 2, right? You can divide by 2, okay, top and bottom. That, oops, there's no answer. That's wrong. Let me see. Nothing wrong, nothing wrong. Let me check one more time. There. Okay, I'm sorry, I forgot this one. R square, right? Oh, because they have right irrational number. That's why they also make a rational number. Okay, so R square goes to go the red 6 times red 6 is 6. 2 times 2 is 4. When you divide it by 2 again, that's the simplest form is what? 3 over 2 is the answer. Okay, yep, so we got the answer over here. Any questions about this? This is a rhombus, not square, okay? This is a rhombus, not square. And also memorize diagonal of a cube. All right? And also rhombus, when you have a length of a diagonal, L1, length of a diagonal, L2, because what these two diagonals are already perpendicular. So the area of this one equals diagonal 1 times diagonal 2 and divided by 2, right? Or maybe you can divide by this one. This red 12 is actually red 12 is what is that? 2 red 3, right? Red 12 is 2 red 3. When you divide by 2, this one is a red 3. This side, how much? 2 red 8 is what? 2 red 2. You know, you can divide by 2. That is red 2. You can use this one if you find this triangles times 4. Red 3 times red 2 divided by 2. That's the area of this small triangle. And times 4 equals to, what is that? This is 2 red 6. So, you know, you can solve this way too. Any questions about number 24? Are you guys with me? Yeah, this is a little bit hard, right? I understand. But actually, when you take your MC8, you cannot, I think, okay, you can finish right after 20, 21, 22, 22, 25. If you, I don't know, if you really go faster, you can try this one. But in case, okay, we try all 25 questions from 2006 to 2020, okay? All the questions we did. Last time we did, you know, do you understand? Last time we did up to number 22, okay? All right, the number 25, what is this? How many perfect cube? Perfect cube is 1 cube, 2 cube, 3 cube, 4 cube. They're all perfect cube. Any number. Keep going. Cube number. Perfect square is 1 square, 2 square, 3 square. That is a perfect square. Okay, perfect cube looks like this way. Any number cubic exponent there. Okay, now we have two numbers over here between, okay, between inclusive, okay, including these two numbers. This is the number 2 to the 8 plus 1 and 2 to the 18 plus 1. This is starting point over here. This is 2 to 8 plus 1 over here. The last one is 2 to the 18 plus 1 over here. In this case, many cubic number, right? Perfect cube numbers over here. We're gonna find this number, 1, 2, 3, 4. How can you find the perfect cubes numbers? The smallest one over here. You should be great at these numbers. But if you don't know this number, can you find this number? Do you remember 2 to the 1 is 2. 2, you have to memorize, okay? 2 to the 4 is 2 to the 3 is 8. 2 to the 4 is
Isn't it 512?
That's right. There is 512. 2 to, you can continue, right? 2 to the 512. 2 to the 9, no, this is 256. 2 to the 9 is 512. 2 to the 10 is now 10,024. 2 to the 11 is 2,048. 2 to the 12 is 4,096. You're going to memorize up to these numbers. Need memorize. 2 to the 8, or you can try, okay? 2 times, 2 times, 2 times, okay? That is 5, 12, no, 256. This number is 256. Using these numbers, what is the first perfect cube numbers? 5 times 5 times 5, 125, too small. 6 times, okay, you can try 6 times 6 times 6, 200, 16, 7 times 7 times 7. How much is this one? 49 times 9 is what? 243, isn't it? No. 49 times 7. 7 times 0.28, that's 340. 16 is too small. The next number is 343. Okay, that is the next number. This is what 6 cube is too small. 7 cube is already 343. 7 cube is the first smallest perfect cube number. The next will be 8 cube, 9 cube, 10 cube, 11 cube, a lot. But how many we go? What is this number? You can use, okay, this number. So find the last number. What is the last cubic numbers? What is 2 to the 18? Can you make this one 2 to the 18 is what? 9 times 2. Oh, no, we need the cube number, right? 6 times 3, isn't it? When you take this out, that is a cubic number, right? Yeah, that's the good idea. So 2 to the 6 is how much? 2 times, 2 times, 2 times. If you don't understand, Just 61. This is 8. This is 8. 64. This is x equals to 64 cubic and plus 1. Just before smallest one is 1. Right after 1 before, there will be 64 cubic numbers. Yeah, that is the last one. So you can count over here. 7 cube, 8 cube, 9 cube, up to 64 cube. That is the last one. How many numbers are there? We don't care about this one, okay? We don't care about this one. Just what? 7, 8, 9, up to number 64. How many numbers? 64 minus 7, last number, minus first number, and plus 1. Is it? Is it okay? So 54 plus 1 is, what is that? No, 57, right? 57 and plus 1 equals 58 numbers. Is it okay? We counted this one. There will be 58 perfect cube numbers there. Any questions about this? Just we find the first smallest cubic number and the last one, highest cubic numbers, and you can count it, okay? Because they all have the 7 numbers. So just count this was 7, 8 2 numbers, 9 3 numbers, 64, how many numbers? We know that last number minus first number plus 1 is last number, first number, and plus 1 is the number of n's. We already know this one, okay? That's the formula. That is number 58. This is the answer number 25, okay? Any questions about this number 25? After class, okay, after class, just figure out by itself, okay? Right, because this is recording, okay? It's gonna be on YouTube. You can take a look if you have any questions, okay? All right, Chan, you have any questions? It's fine. All right, now I'm gonna probe 2019, AMC 8. This is 2019, and the last second class we did, this we did a lot. This we did a lot. This is 2019, last year. We did a lot. Remember 1920, we did 20. Oh, we did everything on this test. Wow. This is a very hard question, so I remember that. Okay. Okay, now move on. The last year, MC, this is 2020, I think. Then, this we didn't do. This one, we did up to number 18. Okay, we did up to number 18. Okay, we're gonna try up to number 19 there. This is 2020. MC 8 from number 19. Okay, all right. Now let's do this question. All right, a number is called flippy. It's a digit alternate. Digit alternate between only 2 distinct digits. It should be 2 distinct digits. It can be 2, 2, 2, 2. Right? 2, 0. Okay, that's fine. 2 distinct. Only 2. After that, repeating. 37. Yeah, 2. Finish. 37. 30. The next is we can stop over here. This is not flippy. 38. 38, that is flippy. 38, 83, this is not flippy. What is this number? 38, 83. Palindrome number. You can see to the left to the right or right to the left. It is the same number. This is a palindrome number, okay? Okay. 1 to 3, that is not 3 digits. That is not go only 2 digits repeating. 2 digits repeating. So what is that? I can make this a 1, 2, 1, 2. 1, 2 is flippy numbers. Okay. All right. That's the idea. Always it should be flippy number. So another constraint over here. The first one should satisfy that is flippy, satisfy the flippy. Second one is we have 5-digit numbers divisible by 15, but the number divisible by 15. Wow, we need to satisfy the both too. It should be flippy and the number is divisible by 15. We have 5 digits over here. 5 digits. 5 digits. 1, 2, 3, 4, 5. But this number 4 digits, not this one. Maybe this is 5 digits. Looks like this numbers. Looks like this numbers. Okay, I'm going to check. The first number is A. Second number is B. Then that equals 2 digits repeating. No, repeating again. A, B, A. And also we can see that first number cannot be 0, right? A cannot be 0. Yeah, we have to know this one. If A is 0, that is a 4-digit number. The number should be exactly like this one. AB, AB, A. That's right, that is the plotted numbers. Now we apply that number is now divisible by 15. All right, divisible by 15. What is the divisible by 15? What that means? Divisible by 3 and also divisible by 5. That is divisible by 15. Another 2 conditions over here. 1 and 2 conditions. That's true. Divisible 5 first. Divisible 5 first. What is divisible by 5? Last digit should be 0 or 5. With this number can be 0 or 5. Right? That is divisible by 5. But A cannot be 0. Oh, last digit, only one choice with 5. Forget about this one. We need only one choice. The last number should be 5 over here. Now rearrange over here. 5, B, 5, B, 5. Okay, now we narrow the searching area over here. Much, much smaller than searching area, right? It should be 5B, 5B, 5. Okay, the next one. Another one is what? Same number should be divisible by 3. What is the conditions of divisible by 3? Sum of all digits. You have to memorize this is divisibility, okay? Sum of all digits is multiple of 3, multiple of 3, or divisible by 3, same thing, okay? Then the number is divisible by 3. What is sum of all digits? Sum of all digits. Sum of all digits. How much? 5 plus, B plus, 5 plus, B plus, 5. 2B plus 15 should be multiple of 3. Last times, I remember I told you arithmetic, modular arithmetic, remainder operation. Do you remember remainder operations? Okay, we are talking about only remainder. Multiple through remainder is what is that? 0. Because that's right. The number is multiple 3. What is remainder over here divided by 3? Remainder is 0. 0 plus what? Yeah, 0 plus 0 is 0, remainder. So what is that? This number should be divisible by 3. Because what? The total is remainder is 0. This is already 0. This should be only one choice. Should be remainder is 0. 2b must be multiple of 3. But this number 2 is not multiple of 3. The next choice is what? B should be multiple of 3. So B number is, B can be 0, right? 0 is a multiple of 3 too. 0 divided by 3 is 0, right? B can be 3, 0, or 3, or 6, or 9. 4 choices are there. So B can be 0, it is the same thing, 0, or 3, or 6, or 9. They are choice. You can move, okay, you can move here. 5, 0, 5, 0, 5, 5, 3, 5, 3, 5. But this 5 doesn't change, okay? 5, 6, 5, 6, 5, 5, 9, 5, 9, 5. How many numbers are there? 4 numbers. Any questions about this number 19? This is a lot of work, right? Division by 3 and division by 5. You need to understand what is divisibility. Okay? All right, that is number 19. Any questions? Is it okay? All right, number 20, take a look number 20. What is this one? Logic, kind of logic, right? Okay, a scientist working through a forest recorded as integers the height of five trees standing in a row. She observed that each tree had either twice as tall as half. Over here, one condition will be as tall as 1 to the right. This number over here is going to be times 2 or times 1/2. The next numbers to the right, right? Not the left. That's correct. Not left, not left, not left. On to the right. This is to the right. Okay, it can be twice or half. But also, unfortunately, some of our data, okay, we don't need this one. He failed the notebook, he noted throw that okay, blank indicate, okay. Based on these observations, the scientist was able to reconstruct the lost data. What was the average height of trees in meters? We're gonna find the average. Sum of all this number 5 and divided by 5. Oh. Let me see, okay. Assigned to data, not enough information. So forest record. Oh, over here. Oh, okay, this is very important. I gotta move it. Now that's fine. Integers, we can narrow the searching area. The next number, when you multiply 2 or multiply by 1/2, it should be integers. Now it's okay. If not, right? Too much difficult. Okay, all right. Now take a look over here. This is number 11. The next number should be integers. When you multiply 1/2, 5.5, not integer, the next choice only what? 22 times 2 available, 22, only one choice over here. What about before that? Before that is a times 2. When you go to a divided by 2 is about 5.5, not good, right? So this is fine. This is what 22 over here, isn't it? 22, all right, times 2 is what is that? 44, no, this is a half, right? Only this is available, 1/2, that is 11, okay? We got 3 numbers. Now take a look at the next numbers over here. The next numbers divided by 2, oh, both working, so we're gonna make one more. We're gonna make one more over here. Still 22, 11, 22. The next number will be 44 is okay, and or, okay, oh, we need one more. 22, 14, 22, 44. The next one is half is okay too, right? 22 times 1/2 is still integers, not 44. 22 times half is 11. That is also integer. That's fine. Another possible answers there. Oh, this is a 44 here, right? You don't need to show. Okay, now what the next? Try again. Times 2 is 88 or, okay. The next one is 44, another divisible by 2, right? 1/2. So 44 times 1/2 is there 22. Okay. Also, maybe we can use this one. Okay. That's fine. We can use this one 22. Over here, when you have 11, the next one is we cannot multiply half. Okay. 11 times 1/2 is 5.5 is decimal. So we have to use this one. Times 2, the next one choice 22. We have 3 cases. Okay. Case 1, follow this one. Case 2, follow this number. Case 3, follow these numbers. Okay. Average. You're gonna find the average, okay? Average is, what is that? You can check it out on the last digit, okay? Oh no, the last digit 5 times is 0, right? Okay, that's the number. We have to add more, okay? How many? 5, okay. So what is the last digit? 1. 2 plus 1 times this is 3, 5, 9, 17. 17 divided by 5 is our last digit is 15, 20, 0.4. This is 0.2. That is not working. This is not working. Now tackle this one. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 4 is 9. 9 plus 1 is 11. Now tackle 11 divided by 5. 10. That is last point. That's 2. This is okay. This is what 2 plus 1 is 3, 5, 6. 6 divided by 5 is what? My God, this is also a 1.2. Wow, we have 2 choices. Okay, we have to check it out. Okay, I'm going to use a calculator, okay, to save time. This is not working. Case 2 equals to 22 plus 11 plus 22 plus 44 plus 22 equals 121. Total is 121 and divided by 5. Divided by 5 equals to 24.2. This one is 24.2. That's okay. But I don't know what happened with it. This one is what? 22 plus 11 plus 22 plus 11 plus 22 again. That is 88. Oh my God, how do I get this one? This should be 0, right? This is 3, 5, 6. Oh, 88, right? 8 divided by 5, last digit, okay? This is 1.0, that is not 0.2, okay? I did it wrong. Okay, we checked this one. So the answer is 20.2, okay? Anyway, we're gonna find what average, okay? That is number 20. Wow, this will take time. All right, move on number 21. What is this? What is this? Check. Ooh. Let me see. Yeah, that is number 22. We have a checkerboard. Can you see that over here? Again, board do I consist of 64? It's okay. You have to understand the question over here, okay? All right, every try understand what is the question. Alternating colors, black and the figure, so the square P, we start from here numbers. And the bottom to top row, we're gonna adjust the Q, moving mark is the one adjoining white square in a row above. Row above, it can't be down, down, you can be going down, okay? Always above. Not coming back. Okay. All right. So we have a consist of, right? We use only white. Okay. 7 steps only. Okay. 1 step, 2 step, 3 step, 4 step, 5 step, 6 step, 7 step. That's fine. Okay. So how many different ways? Wow. Maybe we can try the last this one. 1, 2, 3, 4, 5. Oh, this is just 7. Okay, you can go this way. A little more. 1, 2, 3, 4, 5, 6. No way. No way. Up to here, to the last is what we're gonna try up to this point. This is the maximum to the left. All right, that is the maximum to the left. So forget about this one. We cannot go that way. It never reach right Q in 7 times. All the other one is a symmetry. It's okay, right? Very close. This is a 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7 is okay. 1, 2, 3, 4, 5, 6, 7. So this number is 1, 1, this number 2, 2, 2, this number 3, 3, 3, 4, 4, 4, 5, 5, 6, 6. You can go anywhere. Wow, how can you find this one? Let me think. Just give me 1 minute, okay? Let me find this one. 0, 2, 1. Two, choose one. Okay, 1, 2, choose 1. 3, choose 1. 4, 3, choose 1. 3, choose all. 2 times, 2 times, 3 times, 3 times, 2 times, 2 times. Wow, 124. Okay, that is not working. Okay, just give me a minute. Okay. All right, so we have to use, right, the number of paths. We did it before, right? Okay, no choice. That's not working. That means over here, number of paths. Using number. First one over here, there's 1 block over here, A to B. How many ways to go from A to B? 2 ways. This is 1 way. This is another way, 2 ways. 2 ways, we already know that. So our idea, if you take this number 1, this is number 1. Number 1 going all the way from, okay, there's no coming nor in out. There's still up to all the 1, all the 1. So at this time, 1 plus 1 is 2. That's why we got 2 ways. That's the idea. Now what this one? From A to B. How many ways? You can try this one. 1 way. This is 1 way. Still, there's no adding, right? This is another way. Going up is 1 way. This one is a separate, 2 choice. She can go to the right of you. This is another one, okay? Distribute. But at this time, 1 is coming from left. The other one is coming from down. 1 plus 1 at this not. At this we said not. Not number is 2. Adding. This number 2 move up to right here. Another number 1 is coming from to the left. Okay, coming from here. So at this not, what is that? 1 plus 2 is what? 3. Yeah, there are 3 different paths. You can see it over here. 1, 2, and 3. Do you guys remember this method? the number, okay, pass, okay, using the number. This number is 1. Okay, one more over here. 2 by 2. 2 by 2. I'm going to use P over here, Q over here. They use the P and Q, right? How many ways, different ways to get to the what? Q from P. So I'm going to do this number 1 over here, right? To the right is number 1. This is number 1. From here, that you distribute number 1, number 1, okay? That's not adding numbers. At this time, this also 1 over here, all the way down, still 1, this is 1. But this is not number 1 plus 1, right? This is coming from left, this is coming from down over here. 1 plus 1, this not number is 2, you can write down. The circle is not right number, not number, okay? But this number 2, we have a 2 choice, going to the right, going to the up. So this is a 2 over here, another 2 over here. This is 1 down over here, still going over here, 1 over here. At this point, what happens? 2 plus 1, not number, is 3. This number 3 move over here. That is number 3. From here, what is that? 2 plus 2 is 1, not number, is 4, going to the right. So from the right, we have a 4 approach. Going to the south, we approach 3. Total is what? 7, right? 4 plus 7 is 4 plus 3 is what? 7 different paths. Can you guys do this way? All right, now go back over here. Go. Oops. Oops, this is not. Oh, where is it? Okay, okay. Okay. Now I'm going to use it, right? This point is what kind of a vertex. Okay, we can choose. We choose this point. We start this point, this point, this point, up to here, right, to the left, right? You can go to the left, okay? A little more okay, more than left is not working, okay? So this is our left bound. That's the point. 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 We're gonna pass this one, okay? You're gonna pass this one. So I'm going to do this one. This one. This one. And this one. And this one. This one. And this one too. This one too. You can go anywhere. That's all, right? Are you guys with me? Okay, now let's find the make it big, okay? Looks like a same graph, isn't it? I think that work. If not, we have to use some other different formula, but that's too hard for you. I'm not gonna give that formula, okay? There is another repeating combination, but this is a better, I think, for you. We start from here. I'm gonna take this. Okay, this one can go to the over here. That is number 1. Okay, I'm going to red. This is 1. This is 1. This point distribute, right? To go over here, 1. Over here, 1 over here. But this one move to the right, to the up, another 1 over here. But we're gonna have problem over here. 2 numbers adding, right? 1 plus 1, this not number is 2. This not a number to the right of here, 2 to the left of here. To continue, right? Now take the other side. This is the 1 over here. This one to the road, to the what? This way, another 1 over here. Distribute. So this one up to all the way same, number 1, not adding, not subtract. So at this number, what happened? 2 plus 2 is 1, not number is 4. There is additions. There was additions. This number 4 move up here, move up here. This number 2, okay, already we need the balance. Okay, this number 1 over here, still this is number 1. There's no choice. This number 1, At this point, the number 2 plus number 1 is not number, is 3. Okay, this not number to the going up here 3, to the over here another 3 and 3. But this number 4 move up, approach over here, another approach number 3. And this number not number is 4 plus 3 is what, 7. This number 7 moving go here, another moving over here. Now what happened over here? That's not number. We need to figure out 1 plus 4 here. 1 plus 4, that is not number, it's 5. This not number move to the right. Coming over here, 5 and 7 total is 12. That is another new not number, 7, 12. This not the number 3 over here, that is also 3, right? So 7 plus 3 is what this not number is 10. But this number going over here, 10, another 10 over here, right? Distribute. But this number 12 is coming, and 10 is coming up. The total is what? 12 plus 10 is 22 is not number. This is 10 up to here, no more adding, so still 10, this is 22. So 22 plus 10 is what? 32, right? The last number is 22 plus 10 equals 32. That's this, okay? Any questions about this one? You have to memorize this formula, okay? The number of paths using number 1. Is it okay? All right. The number 32 is that. What are the next numbers? Okay. We're gonna do this later, okay? The voting. This was okay. Okay, you can try this one, number 22. This is a computer programming, okay? If any given numbers n over 2, we divide by 2. If any is odd numbers, 3n times n times 3 and plus 1. Okay, so we start from the last number is 1. This number is 1. This number is 1. But n should be integer, right? We start from here, right? Because that is an example. This is example. That's fine. Up to here, example. But we're gonna go back over here. Going back. Okay. So what happens? Both number is 1 and 1. What is that? What is number n of it? We start the number 1. We start number 1 over here. Going back, what is this one? N is 2, right? 2 over 2 is 1, isn't it? N is 2. Over here, number 1 is n is 0. That is not working. N should be positive. So 3n plus 1 equals 0, n equals 0, not working. This is only one choice. The next number, before this number 1, only number 2 is available. Okay, now we got the number 2 over here. What happened? This is number 2. What happened right before this number? N is 4, isn't it? N is 4. The next one over here, minus 1. Oh, still, n is 1/3. That is not integer. That is not working. Only number 4 available. This is number 4 available. Now if you got the number 4 over here, what is before the number? 8, n equals what? 2 times 4 is 8. What is this one? 4 minus 1 is 3. Now n is 1, right? 3 divided by 3, n is 1. We have over here 2 choices, and it can be 1, 8 or 1. 2 numbers available. Are you guys with me? Looks like complicated, but that's fine, right? Now the next one. Now we have 2 choices, 8 and 1. 8 is first. If this is 8, n is how much? 16. Before the number is 16. And over here, minus 1 is 7, 3 n equals 7, n is not integer when you divide by 3, right? So only 16 is available over here. How much 16? Now the next one, when you choose 1 over here, over 1 again. Only before the n is 2 available, right? This is 2, right? Same things. It's okay. I'm gonna make right the same over here. Only 2 available. Same thing over here, right? Before that, this is only 4, isn't it? Before that, only 4. When you have 16, what happened? And is 2 times 16 before this number is 32. This is 16, minus 1 is 15, 3n is 15, n is 5. Another choice of 5. No. Here, right? N is 5. 15, same number, right? N is 5. How many? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's it. Okay. 1, 2, 3, 4, 5. Oh, this number. We're gonna find this number. We gotta go one more. Okay. We finish up to here. Now you have a 32 over here. Now we got 32 both sides. What is before this number? N equals 64. 32 minus 1, 31, not divisible by 3. That is not working. Now if I got the 5 over here, what happens? The next is 5, right? What happens? N is 2 times 5 is 10. The next one, 5 minus 1 over here, 4. 3 n equals 4. N is not integers. Okay? That is not working. Okay. 5 is only 1. The next one is over here. The last number 4 over here. Both sides, the last number is 4 over here. What happened? This is 4, this is 4. And equals last number 8. This is 4, minus 1 is 3, right? 3 n equals 3, n equals 1. That's possible. Well, we don't need this one, right? Oh, no. This is not. This is 8. From here, binary 1, right? Yeah, that's right. Okay. That is our last number and here. That is the number and possible. The question of your sum of all these numbers. 64 plus 10 is 74, plus 8 is 82, plus 1 is 83, okay? But that is not hard, right? If you understand the programming. That is okay. Wow, too boring. So we're gonna, maybe you can try number, what is the last one? Okay, number 25 is geometry. We're going back over here, right? 24, 25, 24, and 23, okay? Geometry, usually geometry is the easy one, okay? Take one number 25. Now let's see. R1, R2 is the square. S1, S2, S3, that's just R1, R2 rectangle. S is your squares. So this side is 3,322. Wow, very big number. This side is your 220 unit height. What is the side of length? S2. S2 over here. This is square. S is square. Okay, you can use it. This is, I'm going to this is A. This is A square, right? This is a B. This is a B. Oh yeah, we can do that. This is C. This is C. All right. That's fine. Okay, we can set up the equation, right? A plus B plus C. A plus B plus C equals these numbers, right? We got one equation. A plus B plus C equals 33, 22. Okay, now let's see the other side. This is A, we know that. This is how much?
Can you send the notes after class?
Sure, yeah, I can send it out, okay? I'm gonna send out everything today, okay? So this is A, this is how much? This is how much? We need this one, B and C minus B, right? From the C, we take a B, that is C minus B over this side is just C minus B. So 220, how can you find A plus minus B first? Okay, C minus B, that equals to 2020. We got two equations. We have a 3 variable, 2 equations. We need one more equation, right? So what is the length side? You're gonna find the length of side 2 is a B value. Oh God, we don't need any more because we try to find the B value only. This is a system of equations. How can you find the B? Because we have right A same number, C same number. When you subtract those two variables can be gone. Oh, that is a very lucky case. Right? We don't need, right? We have a 3 variable. Actually, we have a 3 variable. We need 3 equations. But in this case, when you use like subtraction, 2 variable will be gone, right? At the same time. My A minus A is 0, C minus C is 0. We got what? B minus B, 2B. That equals how much? Subtract, yeah. Is it okay? Yeah. From the equation, oh, that's the number 20, but number 25 is easier than the other numbers. When you divide by 2 over here, 1302 divided by 2, 6, 12, 5, 10, 2, 651. That's the answer. Okay, that is the valuable, right? The length of this side. Oh, 25 is usually the very hardest one, but this one is not hard, okay? But the idea is that when you tender 3 variable, we might think we need 3 equations. But this time, we don't need the other equations. All right, because these 2 variables, A and C, can be gone at the same time. Okay, that's the idea. Okay, now let's do number 24 first. Okay, we have a large regions paved with the n square grade. This is n square grade. This is one of the example, I think. N equals 3, right? We have 3. 1, 2, 3. Okay. And the total is 3 times 3 is 9 squares. Okay, you can see the 9 squares. 1, 2, 3, 4, 5, 6, 7, and 9 squares. But I'm going to extend this one, n is up to 24. There's the 24 here. There is the 24. The 1, 2, 3, 4, up to 24 here. Down over here, up to 24 here. 24 squares. Is it okay? All right. So we let the S inches aside. This is S. This is S. And the D is between the lengths. This is D. And this is D. Okay. So the ratio of the what? The largest square, okay? The ratio of the largest square out of entire square is what? 64%. Oh, that is not hard, I think, because that's just one ratio problem. Okay. What is the entire area? Each one has S. This is S, S, S. Okay. But when you have a 3S over here, borderline, that is this how much? 4, one more, right? D, 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 D. If the number of triangle square is 3, number of D is 4, one more. So this side is how many? 24 squares. So total area is what? 24 S over here, right? The length over here. And you can add what all this number, right? But in this case, n is 3, what is that? 3s plus 4d, isn't it? 1s, 2s, 3s, 1d, 2d, 3d, 4d. That is the length of this side. So there are 24 squares, is 24s plus one more, this number 25. There are difference from the what? Squares. This is total area. When you make a square, right? This is a square. This one times this one is a square. That's the area. What is the area of these squares? S square, we have what? How many? 576 area. All right, so it's what? 576 s squared. That is equals to 64% is what? 64 over 100. Okay. I think this is okay. I think this is okay. Can you see that 576 is a square number, perfect square, 24 square. When this is square, 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 that was square, you can make what's all the square over here. 576, 24 square, you can be 24. S square, square root is s. The bottom of it also square. So inside the square root of 24, s plus 25d. That is equals to square root of 64 over 100. 64 is what? Square root 64 is 8. Square root 100 is 10. Oh, that's the equation. Very simple. But still we have two variables, but they're asking you find the ratio. But it doesn't matter. Ratio is what? Only two variables in one equation is okay, because we find only ratio. So you gotta express what? S in terms of D or D in terms of S. Okay. So this is 4 over 5. I'm going to use 8. Okay, 10 times 24 is what? 240. S equals to 24 times 8 is 192 S plus 25 times 8 is what? 200D, isn't it? 240 S minus 192 S. This is what? 840. 8S equals to 200. D over here. Okay, so you can use, okay, from here you can use plug-in numbers. If S is 200, D should be 48, isn't it? So 48 times 200 equals 200 times 48. In this way, you can find what the numbers, because we need any numbers is okay, because we're gonna find the ratio. So I'm taking right, S is 200, D is what? 48. You can simplify. Divided by 8 is what? 6. Divided by 8 is 25. 6 over 25 is the answer. Yeah, this one. Okay, choice A is the answer.
Okay.
Okay. Number 25. This is a little hard. I think this is a little hard. 5 different words. This is, we say, counting principles. Okay, countings. 5 different words. I'm going to do this one. 5 different words. A word 1, a word 2, a word 3. They are different, not equal, right? A word 4 and a word 5. But we have 3 students. 3 students, A, B, C. Adam, B, what is the B?
I don't like Bayer.
Okay, Bacon, Charlie.
Yes, bacon.
Bacon, Mr. Bacon. All right. So they can have right all the choices. What about this one? If this is A, Adam has all 5 awards. He got a vowel. Okay, he got all trophies. The next one is what? Another one that B have right all the trophy too. Also, C have all trophy too. This is the rate. This is the number of award. This is the number of boys. A, B, C. What that means? This one, choose this one, this one, this one, this one. Okay. Trophy A is what? A guys, Adam is what got trophy A. Choice B is what? Bikini, no, not bikini, bacon. Okay, choice, award 3 is what? Charlie. Okay, award 4 is what? Adam again. Award 5 is what? Bacon again. That's your choice. So how many total number of choices? This is 3 choice, this is 3 choice, this is 3 choice, this is 3 choice, this is 3 choice. 3 to the power 5, the total is 3 times, so 243, right? There are 243 choices. But there is a constraint over here. There is a constraint. They receive at least 1 award. At least 1 award. There's no blank. There's no, A is no blank, B is no blank, C is no blank. What happened over here? I'm going to try this one. Number choice 1, award 2, award 3, award 4, award 5. We're going to check. A doesn't have any trophy. So only what? B shall available. Only B shall available. Only B shall available. B shall available. B, C, and available. A is 0. Okay, we're going to eliminate, right? Out of this one. Eliminate sum A equals 0, B equals 0, C equals 0, right? We have eliminated this one. Or you can point at the other side. There we said complementary counting. Complementary count. The other side, we count not this one directly. We're going to check, right? Count the other side. After that, take off all this number of side. A is nothing. How many choices? Still, what is that? 2 times, 2 times, 2 times, 2 times, 2 times, 2 times, 2 times 2. How many? 1, 2, 32. In this 32 is why A is nothing. B is nothing, also 32. C is nothing, also 32. Total nothing is 96, which should be out. But in this case, A is 0, B is 0, C is 0, or together is what? Take them out twice. Okay, this is a little bit hard to understand. But in this case, you can add, right? A, B, C. Empty is what is that? Or this one, 1, 2, and or 8, 3. So finally, you can add 3 over here. So 243 minus 96, that is 7, that is 3, 4, 147, and you can add 3. So 150 is the answer. Because when you add this one, A equals 0, B equals 0, C equals 0, 3 times. This we said, maybe this one, okay, I'm going to explain that later, okay? It takes time. This is a Venn diagram. To understand this, okay? If you understand this Venn diagram, okay? Venn diagram topics, it's easy to understand. A little bit confused, right? I understand. When you take over here, 1, 2, 3 is out. When you take this is out, this is out, this is out, this is empty. So we're going to add again. This is a Venn diagram. All right. So if we have a chance later, maybe I can explain a Venn diagram, okay? Because Venn diagram is very important for AMC at 10 and 12. Okay, this is a little hard. I think this is number 25. Go to number 25. We did, right? Okay, we drew up to number 25, 24, 23, and 22, and 21, 20, everything. Okay, I'm going to spread. We did a number 2006 to 2020, every questions. Number 125 completely. Okay, so just so we can try again, and if you need help, you can go to your website. Okay, internet, I send you the link already. You can take the link, okay, and figure out. All right? Okay. Today's our last class, okay? Everybody, maybe some of you take right MC8, Okay, I want you to have good luck. Okay, so maybe if we have a chance later, we can continue to work MC 10. MC 10 is a lot of work, because but you don't have to worry about that. MC 10 has their own formula one by one. Just we're gonna learn the formula and concept, but then the questions look so easy. MC 10 is nothing. If you understand or MC 10, MC 12 is it looks so easy. Okay, just like keep continue to work. Okay, if you really want to be good at math. Okay.
Mhm.
Okay, thank you guys. I'm gonna send out this
Okay.
class note to your email. Okay, maybe I
Happy
can.
holidays.
Okay, next time. Okay, happy holiday and happy new year. Okay,
Thank you.
bye everybody.